Imagine stepping outside on a warm summer night, ready to greet the familiar silver coin that has hovered over humanity since our first campfires. You glance up and freeze. The moon is simply gone. No soft glow, no comforting disk sliding between constellations. In its place hangs emptiness so perfect it feels like a hole punched through the sky. At first, nothing else seems wrong. Crickets still sing, street lamps flicker, and the air smells just as it did a moment ago. Yet your instincts insist something enormous has changed. Astronomers race to their telescopes, expecting a sudden shroud of dust or an eclipse. Instead, their cameras record a tiny patch where starlight bends in a tight, eerie swirl. The moon's entire mass, 70 million trillion tons, has collapsed into an object smaller than a grain of sand, a black hole. News spreads faster than sunrise. Social feeds flood with blurry screenshots of a wobbling starfield where the lunar surface should be. Some people cheer a new cosmic pet. Others whisper end-time prophecies. Children ask whether tides will vanish or wolves will still howl. Governments convene midnight briefings trying to decide if they should calm the public or panic themselves. The truth is both stranger and quieter than anyone expects. A lunar mass black hole sounds terrifying, but gravity cares only about mass, not shape. Earth's cosmic dance partner still weighs the same. It's just wearing an invisibility cloak. So begins one of the strangest nights in human history. Before we worry about doom scenarios, let's unpack what a black hole really is. Using plain, kitchen table physics, picture gravity as the tug of a stretchy sheet. Place a bowling ball on the sheet and marbles roll toward the dip. Now imagine piling so much weight onto one tiny point that the sheet rips right through. That tear is the event horizon, a one-way border. Cross it, and not even light can claw its way back. Here's the twist. Gravity measures how much stuff you have, not how big it looks. Our lunar black hole still weighs the same as the moon, yet its surface, if we can call it that, would be only 0.11 millimeters across, about the width of a human hair. Stand a meter away and its pull feels identical to standing a meter from the old moon's center. The difference shows up only when you get ridiculously close. Space isn't a Hoover. There's a lot of empty room between particles. For something to fall in, it has to pass near that pinpoint horizon. Imagine swapping a beach ball magnet for a pinhead magnet of the same strength. Paperclips still stick if they hit the spot, but most miss by miles. Stephen Hawking showed that black holes aren't perfectly black. They leak tiny amounts of heat. Yet a lunar mass black hole would be colder than the cosmic microwave background that already bathes the universe. Instead of blazing, it would sit there sipping the faintest drizzle of energy. Because its mass is unchanged, the black hole keeps orbiting Earth exactly where the moon did, locked in the same month-long waltz around our planet. No sudden spirals, no new supertides. To the sun, it's merely the same gravitational partner wearing a cloak of invisibility. In short, a black hole sounds monstrous, but when shrunk from a familiar moon mass, it becomes an exotic shape of gravity rather than a cosmic vacuum cleaner. Imagine scooping up the entire rocky moon and pressing it ever tighter, past the point where mountains crumble and atoms scream, until all that mass fits inside a sphere smaller than the poppy seeds atop a bakery roll. That ultimate squeeze defines the Schwarzschild radius. For anything weighing 7 times 10 to the 22nd kilograms, the event horizon would wrap just 0.11 millimeters from the center. To picture how extreme this is, compare volumes. The original moon could swallow about 50 billion freight train boxcars. The black hole version would fit comfortably inside one boxcar's bolt head. The average density jumps from solid rock to something like 10 quadrillion tons per cubic meter, denser than an atomic nucleus, compressing ordinary matter that far demands a runaway collapse. Gravity overwhelms every force that normally holds atoms apart. Electrons merge with protons to form neutrons, and even neutrons give up, surrendering to a point where the known laws of physics hide behind the horizon. From outside, we never see that final plunge. Time itself appears to freeze at the edge. Yet the numbers tell the tale. Because volume shrinks with the cube of radius, a 100 million-fold reduction in size yields a 30 quadrillion-fold spike in density. If such energy were released as light, it would outshine the sun for days, but black holes let no flash escape. Instead, spacetime simply updates to a new geometry. The old solid world is gone, replaced by a gravitational footprint that, at a polite distance, looks exactly the same. Were you to orbit at the moon's average altitude of 100 kilometers above its surface, your path would curve no differently than before. Only within a few dozen meters would the slope steepen into a cliff so abrupt that nothing can climb out. That cliff edge, paradoxically, is now smoother than any polished marble, utterly featureless, perfectly black, and smaller than the width of a human hair. Minutes after the moon winked out, oceanographers watching gauges saw their tide charts tick past the next high water without the slightest hiccup. The familiar twice-daily pulse of bulging and retreating seas arrived exactly on schedule, deviating by less than a centimeter, no more than a brisk onshore wind might raise. Seismologists scanned real-time feeds for a planet-wide jolt and found only the faint rumble of normal microquakes. Gravity, it seemed, had noticed no change. The 70 million trillion-ton companion still pulled with the same strength, only from an invisible dot. High above, a fleet of geodetic satellites traced Earth's monthly wobble around the shared center of mass. A Baryons center hovering 4,700 kilometers under the crust. Laser ranging confirmed the choreography had shifted by mere millimeters. Engineers exhaled. Suspension bridges would not suffer surprise strains, navigation satellites would not drift, and utilities that schedule tidal turbines could keep their timetables. Animals that sense gravitational gradients, like migrating birds, found their familiar cues intact. No sensor could detect the change in shape. Only within a few dozen meters would the slope toward the 0.11 millimeter horizon steepen into oblivion. Yet for anyone who looked up, the night felt hollow in a way instruments cannot record. City skylines lost their hanging lantern. Campfires lost their storytelling spotlight. Coral reefs delayed their annual spawning because the cueing glow never came. Photographers scrambled to relearn exposure settings while astronomers cheered darkness that revealed Andromeda's spiral arms. Owls, moths, and dune mice ventured farther from cover, discovering that deeper shadows blur the line between hunter and hunted. The strongest tide was inside human minds. Lovers missed the silver coin that once timed their kisses. Children asked why bedtime stories describe something they can no longer see, and poets struggled to find new metaphors for love, change, and time. Long before humans counted minutes, the moon's glow was the metronome of life, and its sudden absence rewrites the score in ways both subtle and profound. Out on tropical beaches, sea turtle hatchlings once staggered their frantic dash to the waves by the phase of the moon's halo on wet sand. Now every nest erupts in the same hour of deepest night. Overwhelming volunteers who try to shepherd the confused swarm away from hotel courtyards that blaze brighter than any natural guide. Farther offshore, billions of zooplankton had risen toward the surface under the cover of lunar darkness and sunk again when the disk waxed full. Stripped of that signal, they bob uncertainly, throwing the predator-prey dance of the entire food web. A beat-off tempo. Coral reefs that relied on the full moon's faint blue cue to synchronize one perfect milky blizzard of spawning each year now disperse their eggs in ragged drifts, reducing fertilization rates and leaving hungry fish without their annual feast. In forests, owls and wildcats discover that a darker canopy doubles their hunting territory, while rodents, newly emboldened by the thicker night, nosh on seedlings and change the very architecture of undergrowth. Farmers who once read almanacs that matched planting dates to waxing crescents toss aside the old wisdom. Research stations rush to model crop cycles under a sky where the brightest nocturnal lamp has snapped off. Festivals timed to the first visible crescent, Ramadan, Easter, Diwali's Kartika Deepam, face a quiet crisis of tradition. Mathematic tables can predict the moment, but worshippers miss the communal gasp when a newborn sliver first appears. Meanwhile, human psychology struggles with an emotion for which no word yet exists. A soft homesickness for a companion light. Emergency rooms note a dip in full moon distractions, but a rise in insomnia complaints as darker midnights stretch perception of time. Yet the darker vault also awakens wonder. Children in suburbs finally see the Milky Way, lovers trace constellations that once drowned in glare, and astrophotographers cue online tutorials about framing nebulae from backyard lawns. The moon is gone, but in its shadow, humanity is rediscovering the rest of the universe. The black hole moon sounds like a lurking monster, yet its appetite is chained by simple geometry. Picture the event horizon, a hoop only 0.11 millimeters across, floating 384,000 kilometers away. The odds of a stray atom threading that cosmic needle are so small that at today's dust densities, the hole would need longer than the current age of the universe to gain a single kilogram. Even an unlucky asteroid on a perfect collision course delivers almost nothing. A 10 million ton rock swallowed whole would increase the mass by less than 1 part in 10 quadrillion, imperceptible to Earth's tides or orbit. Could its path ever decay and drag it closer? Simulations show sunlight pressure, solar wind, and gravitational nudges from other planets shift the orbit by millimeters per century, gentle enough that lunar laser ranging stations will track it for eons before danger looms. Only a deliberate push, an ill-considered deflection mission, or a rare encounter with a Mars-sized body could send the singularity earthward, and either scenario would advertise itself centuries in advance. In effect, the black hole is more pet rock than predator, circling patiently, forever hungry but fed by crumbs too sparse to matter. When the moon vanished, it proved that even the steadiest beacon can slip away in a heartbeat, leaving us to navigate by new stars. In that darker sky, we glimpse a humbling truth. The universe is vast, fragile, and indifferent, yet our capacity for wonder keeps shining long after the light is gone. Thank you for watching. For more content, like and subscribe. See you next time.